Hi, I'm David, and this video is about procedural generation in Godot 4. I'm going to walk you through how to randomly generate a dungeon map, and it's going to be based on the dungeons from games like The Legend of Zelda and The Binding of Isaac. To get started, we want to think about how this is actually going to work. Our dungeon map is going to be made out of different rooms. These rooms can be imagined as fitting on a grid, even though not every space will be used. We're going to want to make a two-dimensional array that can hold data about these rooms. But what kind of array would we use for this? We may have made arrays for things like vector2s or integers, but in this case we'll actually want to make our own room class. This can hold all the data we might need. We can hold references to multiple data types, and it can be added to in the future. Let's start by setting up our room scene. First, create a new scene with a node 2D as the root node and name it Room. Add a sprite 2D as a child. This will display our room visuals. Now, we add a script to the parent node. The room script needs several exported textures for different door configurations. We'll have SPU for up-only doors, SPD for down-only, and combinations like SPUD for up-down, SPUDRL for all doors, and so on. In the script, we define our core properties: grid position for position, type for room type, and booleans for each door direction. We also export colors: normal color for regular rooms, and enter color for the starting room. The init constructor takes position and room type parameters. The ready function calls two key methods: pickSprite and pickColor. pickSprite uses a series of if statements to check door configurations and assign the right texture. It is a bit messy to look at and could be done better, but for the sake of the tutorial, this will do just fine. pickColor simply sets the sprite color based on the room type. Normal color for type 0. Enter color for type 1. For visuals, I'm using 15 white sprites for different door combinations. Each is 16 by 8 pixels, with a 1 pixel gutter for doors. Now, let's create our main generation scene. Create a new scene with a node 2D root and name it Dungeon Generator. Add another node 2D node and name it Map Root. This will hold our room nodes. Now add a camera 2D and set its zoom level to 6 times to see the map better after the generation. After you have set up the scene, attach a script to the root node. The script will be called the same as the node it is attached to. We can start by defining how big the level is in room lengths using vector2i for the world size. For my script, I'm treating these as half extents, so the actual size is double this. We'll also need our 2D array of rooms and a list of taken positions. While this information is technically in the room array, having a separate list makes it much easier to check positions using the has method. In the ready function, I do a little math to make sure there aren't more rooms than can fit in the grid. Then I call separate functions: create rooms, set room doors, and draw map. Let's break down create rooms first. We start by initializing the room array to the proper size. Remember that I'm using half extents here. Our first room goes at the center of the grid. We'll want it at vector2.0, so it's centered when we draw the map. This is an offset from the array values. If we had the starting room at 0, 0 in the array, we could only make rooms to the right and bottom. The room type will be 1 to mark it as the starting room. Let's go over the main generation loop. We're setting up a loop that runs once for each room we want to make. We use lerp for calculating odds that affect room placement. This next part is designed to make the map more interestingly shaped. I noticed when first making this script that rooms were very clumped together. This code makes it so some rooms will clump, but others will branch out. The amount is determined by the lerp calculation and how many rooms are left to create. For branching rooms, we keep trying to find positions with only one neighbor. Once we have our position, we add it to the array and taken positions list, calculating the array offset. We construct a room with type 0 for normal rooms. You could add more room types later, but that's beyond this tutorial's scope. Let's look at how we find new positions. We need positions adjacent to existing rooms, since they all need to connect. We grab a random taken position, then randomly choose up, down, left or right. We loop until finding an untaken position within bounds. The selective new position method is similar, but ensures we start from positions with fewer neighbors. Finding neighbors is straightforward but vital. We just count how many adjacent positions are in taken positions. Before drawing, we need to know how rooms connect. The setRoomDoors method checks each cardinal direction around every room to set up door booleans. Finally, drawMap loops through our room array, instantiating room scenes and setting their properties. Finally, for debugging and visual feedback, I add this function. So when you press spacebar or enter, you will generate a new layout. You can experiment with different parameters to get various map styles. If you want me to cover turning this into playable levels or need any clarification, let me know in the comments. Don't forget to subscribe for more Godot tutorials. Thanks for watching.